Right, this is our last concept in 7.5. We're going to talk about rationalizing two-term numerators or denominators, whichever one is specified. Again, remember that rationalize means get rid of the radical wherever. If we're rationalizing the numerator, we're getting the radical out of the numerator. If we're rationalizing the denominator, we're getting the radical out of the denominator. Now remember this, two terms means they're separated by addition and subtraction. So something like the square root of xy over the square root of 3x is not two terms. This is a single term numerator because this is all related through multiplication. But if I had the square root of x plus the square root of y, this is a two-term numerator. So that's what we're talking about, stuff that's separated by addition and subtraction. Okay, and then we talked about this concept of a conjugate. Well, this is where the conjugate is going to come in handy. Conjugate is if I had a term, say the square root of 2 minus the square root of, I don't know, we'll say x. Then the conjugate to that is the square root of 2 plus the square root of x. Okay, so if we're looking at 6 over 2 minus the square root of 7, and I want to get rid of this radical in the denominator, I can't just multiply this by the square root of 7, because when I do, if I tried, it was like, well, hey, I'll just get rid of this by multiplying by the square root of 7. Remember that I would have to distribute, and that would give me 2 square roots of 7 minus 7, and then I would still have this radical in the denominator, and we would just keep going on and on like this forever. Okay, so when you have a two-term denominator or numerator that you're trying to rationalize, you have to multiply it by the conjugate. So in this case, our conjugate would be what? Same two terms, opposite signs. So it would be 2 plus the square root of 7. Whatever you do to the denominator, you have to do to the numerator. So let's see what happens here. I gotta FOIL the denominator. When I FOIL, 2 times 2 is 4. I get plus the square root of, plus 2 square root of 7 minus 2 square root of 7 minus 49, or square root of 49. This is going to be 4. These sum to 0. 2 square root of 7 minus 2 square root of 7 is 0. Square roots of 7, so we have none. And this minus 49 is going to simplify to 7. So on the bottom, we would just have a negative 3. So I'm going to rewrite this. So this looks like 6 times 2 plus the square root of 7, all over just a negative 3. Well, if I want to simplify this, I do not want to distribute here, because I can actually simplify before I can distribute. Remember that this 6 is related through multiplication, so I can cancel it because it's a factor. Both the 3 and the 6 have something in common, and I can take a 3 out of here and a 3 out of here. When I do that, if I divide that by 3, I get a 2. And that is all divided by a negative 1. Well, I can just take this negative here. When I divide something by negative 1, I'm just going to float that negative up to the top here. And I would get negative 2 times 2 plus the square root of 7. You can leave it in this format. You do not have to FOIL it out or distribute it. So you get negative 4 minus 2 square roots of 7. You don't have to do that. You can just leave it in its factored form there. So I suggest leaving it that way. So this is rationalizing the denominator. Again, I wanted to get rid of this square root in the denominator, but the only way to do that when you have a two-term denominator is to multiply by its conjugate. Let's do a couple more of these for practice. All right, so this time let's do the square root of 2 minus the square root of 3 over the square root of 2 plus the square root of 3. Again, we're rationalizing the denominator here. So I want to get rid of the radical in the denominator. The way I'm going to do that is I'm going to say, hey, this is two terms, so I need to find its conjugate. Well, the conjugate is the same two terms with opposite signs. Same two terms, opposite signs. Whatever I do to the bottom, I have to do to the top. All right, so again, when we FOIL this out, this is going to be tricky, but when we FOIL this out, we get the square root of 2 times the square root of 2, which is the square root of 4, which is just 2. The outer and the inners are going to sum to 0. That negative square root of 6 plus the square root of 6, these sum to 0. So I'm going to quit doing these because they're always going to sum to 0. That's why we're using the conjugate. When you use the conjugate, the middle terms sum to 0. It's like magic. That's why we're using it. Okay. Then this lasts, the square root of 3 times the square root of 3 is going to give me a minus 3. Again, square root of 3 times the square root of 3 is a minus square root of 9, and the square root of 9 is 3. So on the bottom, we literally just have negative 1. Okay. But what do we have on the top? These are not conjugates. This is a binomial squared. I have the same two terms twice, so I have to FOIL these, just like we did down here, but the middle terms aren't going to sum to 0. Let's see what happens. Again, that square root of 2 times the square root of 2 is the square root of 4, which is just 2. Then I get a minus 2 times 3 under the square root, which is 6. I get a minus square root of 6 again, and a plus square root of 9. Square root of 9 is just 3. Okay, so then I'm going to look at these and say, wait a second. I can actually combine these constants, and I can combine these. These are like terms. This is one of those and another one. When I have a negative 1 plus a negative 1, I get a negative 2. So I'm going to have negative 2 root 6. And this is going to be 2 plus 3, which is 5. Plus 5, all over a negative 1. What does that negative 1 do? Well, this negative 1 belongs to both of these terms. If I divide negative 2 square roots of 6 by negative 1, I'm just going to get 2 square roots of 6. If I divide 5 by negative 1, I'm going to get minus 5. So this is the most simplified version of this denominator. Again, my goal was to get the radical out of the denominator. Want to try another more difficult one here. Give yourself a minute to try to work through this. It'll be super good for you. Let's try 4 square roots of 5 plus the square root of 2 over 2 square roots of 5 minus the square root of 2. Again, we're rationalizing the denominator. Okay, rationalize the denominator. So this is a 2-term denominator, so I want to get rid of the radicals in the denominator. I'm going to do that by multiplying by the conjugate, which is going to be the same 2 terms with opposite signs. Whatever I do to the bottom, I have to do to the top. And I know, I'm so smart that I know this, when I do these middles, they're going to sum to 0. Remember, that's why we use the conjugate. So I'm only going to do the first times each other and the last. Well, on the outside, I have 2 times 2. That's going to give me 4. The square root of 5 times the square root of 5 is 25. But the square root of 25 is just 5. So 4 times 5 is going to give me 20. Okay, and when I do the lasts, I'm going to get the square root of 2 times the square root of 2. That's going to give me a negative square root of 4, which is minus 2. So on the bottom, we have 18. It's kind of weird. All right, so now I'm going to look at the tops. The tops, I'm going to have to FOIL. When I FOIL, the first times the first, 4 times 2 is 8. Square root of 5 times the square root of 5 is just 5. Square root of 25 is 5. So 8 on the outside, 25 on the inside, and when I multiply those together, I'm just going to get 40. All right, then I'm going to do the outers. So 4 times 1 is going to give me 4. The square root of 5 times the square root of 2 is going to give me square root 10. Now I'm going to do the inners. 1 times 2 is a 2. Square root of 2 times the square root of 5 is the square root of 10. Then I'm going to do the lasts. Square root of 2 times the square root of 2 is the square root of 4. But the square root of 4 is just 2. Okay, and when I'm looking at these, I can simplify this square root of 4 square roots of 10 and 2 square roots of 10. These are like radicals, so I can combine their coefficients and get a plus 6 square root 10. So I can also combine this 40 and this 42, and this 40 and this 2 to make 42 plus 6 square roots of 10 all over 18. Well, this is where it gets a little bit tricky, because I can actually remember that this 18 belongs to both of these terms. It's like it says this, right? So the 18 belongs to both. Well, you'll notice here, if you look at the fact that there's an 18 here on the bottom, when all 3 of these terms have something in common, again, not this radical, because I need the coefficient, because it's related through multiplication. I can only cancel factors. I can't cancel this radical here. All 3 of these have a 6 in common. So if I took a 6 out of the 42, then I would just have 7. If I take a 6 out of this 6, then I just have 1 square root of 10. And if I take a 6 out of this 18, then I just have a 3. So this is 7 plus the square root of 10 over 3. That is all the way simplified. This right here is a little tricky. Again, the way that you're going to look at this is you're going to say, hey, if all of these terms have the same factor, you can factor it out. You could look at this like factoring out the greatest common factor. I could say that 42 has a factor of 6. That would leave me 7 plus the square root of 10. Right? So you can see that 42 plus 6 root 10, if I factor out a 6, would look like this. And this is going to be 6 times 3. You can cancel those 6's, and you can see that these are the same. Okay, so that was a really tricky one. That, again, is rationalizing the denominator. My goal is to get the square root out of the denominator. There's no more square root in the denominator, so we are good to go there. I want to do 2 more problems where we're rationalizing the numerator of a 2-term numerator. Let's go. Here and say, now this time my goal is to get the radical out of the numerator. Well, right now there's a 2-term numerator, and whenever I have 2 terms, I have to use the conjugate. So I want to multiply by 2 plus the square root of 11. Again, this time we are rationalizing the numerator. So I'm trying to get that radical out of the numerator. Whatever I do to the numerator, I have to do to the denominator. So the 2 times 2 is going to give me 4. The outer is going to give me a positive 2 square roots 11 and negative 2 square roots 11, which will sum to 0. Again, that's why we use the conjugate. So I'm just going to not write those because they're going to sum to 0 anyways. The square root of 11 times the square root of 11 is just going to give me 11. I'm going to have a negative 11. So 4 minus 11 is going to give me a 7 on the top. All right, so I have a 7 on top. On bottom, I have this 6 times 2 plus the square root of 11. If the 7 could cancel with this 6, or if it was a number that could say like it was 8 and I could cancel 2's out, then I should. But in this case, 7 and 6 have no common factors, so I'm just going to leave it like this in its factored form. Okay, so that's rationalizing a numerator. That's not too complicated. I want to do one more where we're rationalizing the numerator, but with a little bit of a tricky term here. So we want to rationalize this numerator. So again, all I care about is getting the radical out of the numerator. Because this is a two-term numerator, Again, we're rationalizing the numerator this time, not the denominator. Because this is a two-term numerator, I need the conjugate of these two terms. Conjugate is the same terms with opposite signs. So whatever I do to the numerator, got to do to the denominator. Okay, and when I multiply this x, square root of x times the square root of x, it's going to be the square root of x squared, which is just going to give me x. The outer is going to be a negative xy, and the inner is going to be a positive xy. Those are going to sum to 0. That's why I use the conjugate. This last is going to give me a minus square root of y squared. Well, the square root of y squared is just y. So on top I have xy. But what do I have on the bottom? Well, when I go and FOIL this, I get the square root of x squared, which is x. Okay, and then I'm going to do my outer, which is a negative square root of xy, and the inner, which is another negative square root of xy. These are not going to sum to 0. There's two of them, because these are not opposite signs. They're the same sign. So I'm going to have two of these. Here, when I do the last, I'm going to get the square root of y times the square root of y, but a negative times a negative is going to give me a positive, so it's a square root of y squared. Square root of y squared is just y. I can combine these, not sum them to 0, but combine them to get a negative 2. There's a negative 1, negative 2 square roots of xy. So on the bottom, I'm going to have x minus 2 square roots of xy plus y. Now, maybe you're tempted to cancel this x with this x, or this y with this y, or both. I can't do that. You can't do that because, like I said before, it's the whole enchilada or nada. So this is a single factor connected through addition and subtraction. I can only cancel things that are related through multiplication. So again, these are connected through addition and subtraction. So I either cancel the whole thing or I cancel nothing. If I had xy over, I don't know, x times 2y or something like this, I could cancel these and just leave behind the 1/2. But because they're related through addition and subtraction, I cannot do this. So here is my rationalized numerator. There's no radical in the numerator. That was my goal.